Hey, student, how are you? Welcome to our session on quadratics, graphing, vertex form. We'll go through 3 examples. Number 1, here is our quadratic given in vertex form. Let's start by finding the vertex. We use the opposite sign of h, shifted to the right 2, and then k, our vertical shift, is -6. Our vertex is 2, -6. Let's graph it. 2, -6. There's our vertex. Now our axis of symmetry, the line that cuts the graph in half, is x equals 2. To find another point, let's choose an x value close to the axis of symmetry. Let's see. Let's use x equals 1, or you could use x equals 3. We're going to substitute x in to find y. Substitute x in to find y. I'm going to do x equals 1 and substitute 1 in for x. And then I'm going to use my order of operations to simplify. Parentheses are first, exponents are next. -1 squared, -1 times -1, negative times a negative is a +1. And 3 minus 6, you can always use a calculator. 3 minus 6 is -3. So I substituted 1 in for x and got -3 for y. Here is another point on our graph. 1, -3. And then using the axis of symmetry, I know that there will be a mirrored point right here on the other side of our axis of symmetry. And I can connect these 3 points. And here is a rough sketch of our parabola, the graph of this quadratic. Number 2. Here is our quadratic given to us in vertex form. Let's identify the vertex. Inside the parentheses, we'll use the opposite sign of h, +4. And there is no k, so we will use 0. Our vertex is 4, 0. Let's graph it. 4 to the right, up 0. 4, 0. X goes left and right, y goes up and down. So 4 to the right on our x-axis. Let's find another point. We want to use a number close to 4 so that we can use our axis of symmetry to get a mirrored point on the other side. Now you could substitute a number close to 4, x equals 3 or x equals 5. However, we have a -3/2, a fraction. And if we use 3 or 5 to substitute in for x, you're going to get a fraction. Now, if you have the ability to graph -1.5 or -1/2, you can. But I don't have fractions on my graph, So I'm going to use x equals 2, or you could use x equals 6. And we'll substitute x in to find y. I'm going to use x equals 2. Substituting, x is 2. And using our order of operations to simplify. Parentheses first, 2 minus 4. You can always use a calculator. Exponents are next. Negative 2 squared, negative times a negative is positive 4. And then I like to do my fractions like this. Negative 3 over 2. I'm going to use a dot to multiply 4. You can make 4 into a fraction, 4 over 1. And we multiply fractions straight across, top and bottom. Negative 3 times 4, we get negative 12. And 2 times 1 is 2. And then a fraction is division. So divide. Negative 12 divided by 2, we get negative 6. You can also use a calculator. Just make sure to put parentheses around your fractions. We substituted 2 into our quadratic and got negative 6 out. Here is another point on our graph. Let's graph it. And we'll have a mirrored point over the axis of symmetry. Connect, and we get a rough sketch of our parabola. And number 3, last example. Got an extra graph there. Interesting. Last example. This quadratic is in vertex form. I could write the vertex form so that it is more clear for you. And there we go. We can see that our h is 0. There's nothing inside the parentheses with x squared. So our h, the x coordinate of the vertex, h, is 0. And then k is 5. K is 5. Let's graph this point. 0, up, 1, 2, 3, 4, 5. Here's our vertex and our axis of symmetry. And we can use an x value close to the vertex x value. So you can use x equals 1 or x equals negative 1. I'm going to use positive 1 to substitute. Substitute positive 1 in for x to find y. Using our order of operations. And we get our second point, 1, 8. And we'll graph it. And using our axis of symmetry, negative 1, 8 will be another point. And connecting, and there is our graph. And that concludes Quadratics Graphing Vertex Form. Thanks so much for joining our session, and I'll see you next time.